We are going to work with limits of function where variable is running to approaching to infinity. Okay, let's assume we have limit x approaches to infinity 1 minus x. So what's gonna happen? We said in the previous video we wanna plug in the value where x is approaching to, right? So if I plug in, let's say 1 minus this infinity, the result, so let me put minus also, 1 and negative infinity. Result is going to be negative infinity. Why? Because 1 is way too small in comparing to negative infinity. Now, to understand now, to make you help you to understand why is it negative infinity, I'm going to use very simple basic way, although it's not the best way to prove, but for understanding, basic understanding, that will work. It will work enough. So let's assume I'm taking x is equal, I'm doing drafting on the side. Let's say x is equal 10. Then 1 minus x is going to equal negative 9, right? Next, x is equal 100. So 1 minus x is going to be 99, negative. X is equal 1000. 1 minus x is going to equal negative 999. So x dot dot dot, x is equal, let's say, 1 million. So 1 minus x, it's going to be equal 999,999, 999,000 and 999. Let me move a little bit here so you will have space to see well what's happening. 1 minus x will be equal negative 999, comma 999. Okay, and practically what's happening here? It's running negative 9, negative 99, negative 999, so it's running towards negative infinity. Right? That's the smallest number. It's getting smaller and smaller and smaller until it becomes negative infinity. So therefore, it's going to be equal negative infinity. So this is another way to explain. And first one, it's 1 minus infinity, 1 and negative infinity. 1 is nothing comparing to negative infinity. That's why negative infinity absorbs 1 just like nothing. Next one. Number 2, limit x approaches to infinity. What do we have here? X squared minus 2x minus 3. How much do you think it will be? If you plug everywhere x squared, 2x, you plug infinity, so and then minus 3 means nothing, right? So answer is going to be infinity. Now here I would like to that just crossed my mind, squeeze in another example that will help you to understand better. Hold on, let me pull this down. It's just now it crossed my mind. So let me put this way, number 2. Limit x approaches to infinity. Instead of 1 minus x, I'm going to put x minus 1. So my x is infinity, and then minus 1 doesn't mean anything comparing to infinity, right? I'm going to get infinity minus 1. So the answer is going to be infinity, not negative 1, right? It's going to be infinity. See the difference? Okay. It's just like 3, in this case, this is going to be, let's say, 3 minus 1. For example, it's positive 2. Here, if I put 1 minus 3, it's going to be negative 2. So, something like that. All right. Next. This was infinity. We already figured out. Next one. 1 over x. Limit x approaches to infinity. Take a guess. Well, if I plug, I'm going to get 1 over infinity. 1 over infinity always equals 0. Why is that? I'm going to explain again, very simple way. So, which means when we plug infinity, that's the limit of it. But I'm going to take numbers that gradually are going to increase. Okay? I'm taking, let's say, let's start from 10. 1 over 10 is equal 0.1. Yes? I'm taking 1 over 100. So I'm increasing. 1 over 100. It's going to be 0.01. 1 over 1,000. It's going to be 0.001. Dot, 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 dot. If I put 1 over million, it's going to be 0.12345 So what is happening? It's getting smaller and smaller and smaller, and it's running, result is running to 0, right? So it's getting as close as possible to 0. As while this number in denominator is growing to infinity, right? Okay. The other way to explain, when numerator is the same, just like we have it here, numerator is the same. See, everywhere I have 1, 1, 1. As the denominator grows, result is always going to be smaller. The greater denominator, the smaller is going to be result from division, okay? All right, next example, number 5. Accordingly, when limit x is running to 0, I want to show this. 1 over x, where we have 1 over 0, it's going to be equal infinity. You can derive from this case. And the other way, the same way, you can, since you are dividing by 0, you get a number, let's say million, right? This time you can take, you can go from here, from million you can go to 10 because it's running to 0, right? So million, thousand, 100, 10, and so on. You will see that result, it will grow to it's gonna grow to infinity. It's gonna get bigger and bigger. So in this case, it's gonna go from here, right, to infinity because it's getting bigger and bigger, these numbers. okay? Or you can arrive from 1 over infinity equal 0. Number 6 problem. Limit 1 over x minus 99 when x approaches to infinity. So if we plug in, instead of x, we plug infinity. So does 99 matter? Of course not. But infinity is like eternity, space. What is there? 99. Let's say any planet. It's a drop comparing to entire the eternity. So therefore, it's going to be equal the same thing like 1 over infinity, which is going to be equal 0. And the same way, limit x approaches to infinity, negative 3 over x cubed. I can put even x to power 100. Doesn't matter because it's nothing comparing to infinity. So I still will get negative 3 over infinity. I'm going to get 0. Another example, limit x approaches to infinity, 5 over x to power 4 plus x minus 9. As long as you have x in denominator and x approaches to infinity, that's it. You are going to get the infinity in denominator. Once you get infinity in denominator, result is going to be 0, period. Okay, let's move to next 2 interesting cases I'm going to show you. Interesting case is going to be limit two-thirds to power x approaches to infinity. So if I plug this infinity here, 2/3 to power infinity, it's gonna be, interestingly enough, it's gonna be 0. Let me explain, very basic way again with plugging numbers. So what do we get? Let me take 2/3, change the color, 2/3 to power 1, 2/3 to power 2, 2/3 to power 3, and take 2/3 to power 4. As you can see, our exponent is increasing, right? Because y replaced with infinity. So exponent has to increase and run to positive infinity, right? It will continue. So let's get the result. To power 1, it's going to be 2/3. To power 2, it's going to be 4 over 9. To power 3, it's going to be 8 over 27. And to power 4, it's going to be 16 over 81. Now, let's compare these fractions. By the way, if you don't remember how to compare fractions with different denominator, you can go to my basic math playlist, and I explain there on the video. I have a video comparing fractions. So 2/3 and 4 over 9. So what do we get? 2/3 is gonna get 2/3 is greater than 4 over 9. Next, 4 over 9 is greater than 8 over 27. 8 over 27 is greater than 16 over 81. How I am comparing? I am bringing to the same denominator, like let's say 9 over 27. 4 over 9 and 8 over 27. Common denominator going to be 27, right? So if multiply this by 3 to bring to the level of 27, I'm getting 12 here, 27 here. So when denominator is the same, numerator is deciding if fraction is greater or less. Well, 12 is greater than 8, so it's greater. So what do we get? It's running the result as exponent is increasing. The result is decreasing, right? Getting smaller and smaller and smaller, eventually running to 0. Now it's going to be completely opposite case if I plug, let's say flip it. Instead of 2 over 3, I write down 3 over 2. It's going to be 3 over 2, which means we are getting improper fraction, right? 3 over 2 is 1/2. 3 over 2 to power again running to infinity. Otherwise it wouldn't be interesting. So if I raise to power infinity, guess what's going to happen? It's going to become result infinity. Yes, that's right. So let's check. I'm going to check it again. Like I said, this explanation is not professional proof to the result, but this is very basic, simple explanation that will help you to make sense and understand. Okay, let's do it. So I'm taking 3 over 2. So since our exponent is running to infinity, I'm going to grow, right? The exponent. 3 over 2 to power 1. 3 over 2 to power 2. 3 over 2 to power 3. And 3 over 2 to power 4. So as you can see, it's increasing. 1, 2, 3, 4. So indeed, we are heading towards infinity. Now let's see what's going to happen to result. So here we get 3 over 2. Here we get 9 over 4. Practically flipping these answers. 27 over 8. Yeah. And lastly, 81 over 16. Okay? What is happening to result? It's going to be the following. So 81 over 16, it's equal 5. 5 times 16 is 80, and 1 over 16. Whoever need to refresh memory about converting improper fraction to mixed fraction, go to my basic math playlist, find the video there. And 3 over 2 is equal 1 and 1 over 2. 9 over 4 is 2 and 1 over 4. 27 over 8 is 3 and 3 over 8. So what is happening? As the exponent is increasing, see, the result is also increasing, right? Getting bigger and bigger and running towards infinity. And this is how you are getting the result. While in this case, as we can see, 2/3, 4 over 9, 8 over 27, 16 over 81, it's getting smaller and smaller and smaller and running towards to 0. Okay? All right. So Let me write down also properties of limit. Okay, let's assume, what do we have? Let's assume limit of f of x x approaches to c is equal L, okay, and limit f of x and x approaches to c again, which is equal k. To remind you, real numbers is a set of real numbers that made by combining the set of rational numbers, set of irrational numbers, natural numbers, okay, whole numbers. So all numbers, fractions, I mean rational numbers are fractions practically, and irrational numbers. So all numbers that exist in the world, those are real numbers. All right. So in that case, if limit f of x is L, limit f of x is, I mean g of x, hold on, limit g of x is equal k, then number one, if we have constant b that has nothing to do with limit and x approaches to c, that constant come out and we have limit f of x, x approaches to c, and limit f of x when x approaches to c is equal L. So we will have b times L. Okay, so let's solve some examples. I'll give you some basic example. For, let's say, assume we have limit x approaches to -1. So my real number is -1 here. And I have 6x squared minus 1. I can write down limit 6x squared x approaches to -1 minus limit 1 x approaches to -1. So what do we get here? Result is going to be, I'm taking 6 out because this 6 is a constant and it's not being affected by the limit. So it's going to be 6 limit x squared x approaches to -1, okay, minus limit 1, because it's a 1 also constant. Actually I can write down -1 might -1 might as well, but this is not this -1 I will plug here. It will be just 1 because it's a constant. 1 is a constant and it has nothing to do with the limit. So I'm just leaving that 1, and because we had here negative, so it's going to be minus this 1. Okay? Again, this minus 1 has nothing to do with this limit, negative 1. It's just here we have minus, and a limit of, it's a 1, it's a constant, 1 comes out. And the result is going to be 6. So I'm plugging negative 1 here, times negative 1 to power 2 instead of x squared, minus 1. And we get negative 1 squared is 1. So 6 minus 1, we get 5. Okay, second one. Sum or difference. This is going to be the following. The limit of sum or difference for two functions is equal sum and difference of their limits. One more time. Let me write down. Limit of sum of difference of two functions okay, x approaches to c, is equal sum or difference of limits of these functions. The limit of f of x we have right at the beginning, that is L. Limit of g of x we have k. So we are getting L plus minus k. Okay, so taking example, limit x approaches to 0, and we get x cubed minus x plus 7. So we know already, we just take 0 plugging. Where from it's coming? Based on this property, because I can write down limit x cubed, x running to 0, minus limit of x running to 0, and plus limit of constant x running to 0. So what do we get? Limit of x cubed, plugging 0, 0 cubed, they are going to get 0, right? Minus limit of x is approaching to 0, so it's going to be 0, plugging 0. And limit of 7, it's a constant, has nothing to do with limit at all, so 7 comes out with no problem. And answer is going to be 7. So in this problem, I used n minus, n difference, and addition. Moving to next one. Next property is going to be product. So the limit of product of the two functions is equal a product of their limits. One more time. The limit of product of two functions is equal product of their limits. So this is the first property. Okay, what do we have? Limit x approaches to 0, f of x times g of x is equal limit, I'm sorry, it's habit 0, x approaches to a, x approaches to a, because we are using general format, right? X approaches to a, it's gonna be limit of the f of x times limit of g of x. Which is going to be equal limit f of x, it's going to be L, limit g of x, it's going to be K. Okay, taking example. So limit x approaches to 2. What do we have? X minus 2, x minus 1, let's take, times x plus 2. This is equal limit x approaches to 2, x minus 1 times limit of product equal product of limits. So times limit of x plus 2, x approaches to 2. So what we get from here, plugging instead of 2 in the first limit, we're here plugging this 2, right? I'm going to get 2 minus 1 times, plugging 2 in the second one, I'm going to get 2 plus 2. And I'm getting 1 times 4. Answer is 4. Next, I'm going to do quotient, property of quotient. Okay, limit f of x over g of x, and x approaching to a or c, doesn't matter. That is going to equal limit of f of x is L, limit g of x is K. Now, since we have here fraction division, we always have to put condition, denominator cannot be equal 0, right? There we go. All right. Let's see. Example. Limit x approaches to 2, x plus 2, x minus 1. This is going to be equal limit x approaches to x plus 2, limit x approaches to x minus 1. So that is equal. So plugging here 2, and here also plugging 2, and we are getting two plus 2, and here we are getting 2 minus 1, and we get 4 over 1 equal 4. And lastly, the property of power. The last one is going to be the property of power. So what do we have? Limit x approaching to a, f of x to power n is equal entire limit, everything goes under, can be included under this power n, degree n. All right, and n is going to be, n is can be natural number. Uppercase n is a natural number. What is natural number? From starting from 1 and whole numbers increasing, 1, 2, 3, 4, 5, 6, 7, and so on. Can be natural number. 0 is not included in the natural number. The 0 is a whole number but not natural number. All right? Okay, so let's do it. Limit x approaching to -1, so 6x squared minus 1 cubed is equal, parenthesis, limit x approaches to -1, 6x squared minus 1, closing entire parenthesis, it's going to be cubed. So if I plug -1, I'm getting 6 times -1 squared minus 1, and all this is going to be, let me put the square bracket so for readability to power 3, and the result is going to be 6 times the 1 is 1 minus 1 is 5. 5 to power 3 is equal 125. Okay, that's all. So I hope this video helped you to get better idea about limit, and I'll see you in next video. I will record limit of trig functions. Okay.